Welcome students. This module is intended for students of third year Bachelor of Science in Physics, Semester 6, course code PYC108, course title Atomic and Molecular Physics. Unit 1 Hydrogen Atom, module name Schrodinger equation for hydrogen atom, separation of variables, quantum numbers N, L, ML. I am Dominic Nelson Robo from St. Xavier's College, Mapsa. Outline of today's lecture: to solve Schrodinger equation for hydrogen atom in spherical polar coordinates by method of separation of variables and to obtain quantum numbers N, L, ML. Qualitative description of quantum numbers N, L, ML. Learning outcomes: at the end of this lecture, students will be able to solve Schrodinger equation for hydrogen atom using the technique of separation of variables and to obtain quantum numbers N, L, ML, and also describe the quantum numbers. So let us begin with our lecture. A hydrogen atom consists of a proton of charge plus q and an electron of charge minus q revolving around it as shown in the diagram. Let P be the point or position of electron, that is xyz, P, xyz, and O be the nucleus or the position of the nucleus. The distance from O to P is, let it be r, and angle theta is the angle made by the projection of point P on the positive z axis, whereas angle phi is the angle made by the projection of point P on the xy plane with the positive x axis. Now, Schrodinger equation in Cartesian coordinates is given by equation 1, that is d square psi by dx square plus d square psi by dy square plus d square psi upon dz square plus E minus V psi equals 0, where V is the potential energy and is given by minus E square upon 4 pi epsilon naught r. Now we need to convert rectangular coordinates into spherical polar coordinates. So we use x equal to r sin theta cos phi, y is equal to r sin theta sin phi, z equal to r cos theta, where theta is equal to cos inverse z by r and phi is equal to tan inverse y by x, and r equal to root of x square plus y square plus z square. Now we substitute equation 2 in Schrodinger equation 1, which will give us 1 upon r square d by dr brackets r square d psi by dr plus 1 upon r square sin theta d by d theta sin theta d psi by d theta plus 1 upon r square sin square theta d square psi by d phi square plus 2m by h cross square E minus V psi equal to 0. Now we substitute the value of potential energy and multiply the entire equation by r square sin square theta, which will give us equation 3 as shown in blue. This equation 3 is Schrodinger equation for hydrogen atom in spherical polar coordinates. We use the method of separation of variables to obtain the different quantum numbers. Therefore, we write psi which is a function of r, theta and phi as capital R, which depends upon variable small r, capital theta which depends upon small theta, and phi, capital phi, which depends upon the variable phi. Now we find out the quantities d psi by dr, d psi by d theta, and d square psi by d phi square. These are equations 4. Note, in all further discussion, the partial derivative of the function r with respect to the variable r will be pronounced as dr by dr. In the same way, partial derivative of the function theta with respect to variable theta will be pronounced as d theta by d theta, and the partial derivative of the function phi with respect to variable phi will be pronounced as d phi by d phi. Now we substitute equation 4 in equation 3 and divide the entire equation by capital R, capital theta, capital phi. The equations 4 are given in red. Therefore, we obtain sin square theta by r d by dr into r square dr by dr plus sin theta by theta d by d theta sin theta d theta by d theta plus 1 upon phi d square phi by d phi square plus 2mr square sin square theta by h cross square into e plus e square upon 4 pi epsilon naught r equal to 0. This equation can be rewritten as by taking the term 1 upon phi d square phi by d phi square on the right hand side, and that gives us equation number 5. Now the left hand side of equation 5 depends on variable r and theta, whereas the right hand side only on variable phi. Now this equality will only hold if both sides of equation 5 are equal to the same constant. Let us say it's ml square. Therefore we can write equation 6 as minus 1 upon phi d square phi by d phi square is equal to ml square, and substitute this equation 6 in equation 5 and dividing by sine square theta, which will give us equation 7. Now if you observe equation 7, the left hand side depends upon r and the right hand side depends only on theta. Therefore the equality will hold only if both sides of equation 7 are equal to the same constant. Let us say it's L into L plus 1. Therefore we get equation 8 which depends only upon r, that is 1 upon r d by dr, r square dr by dr plus 2m r square upon h cross square e plus e square divided by 4 pi epsilon naught r is equal to L into L plus 1. And equation 9 which depends only on theta, that is ml square divided by sine square theta minus 1 upon theta sine theta d by d theta sine theta d theta by d theta is equal to L into L plus 1. Thus we have three equations with separated variables. The first equation 6 is in terms of phi. The equation 8 is in terms of r, which is also called the radial equation, and equation 9 which depends only on theta. Now these equations can be solved to obtain the quantum numbers. What are quantum numbers? The set of numbers used to describe the position and energy of an electron in an atom are called quantum numbers. There are four quantum numbers, namely total or principal quantum number n, orbital quantum number L, magnetic quantum number ml, and spin quantum number ms. What is the use of these quantum numbers? They provide solutions that are acceptable to Schrodinger equation for hydrogen atom. The first quantum number n, which is called the total or principal quantum number. The quantization of electron energy is described by the total quantum number, and it is related to the energy of electron as E is proportional to 1 upon n square. Now the values that n can take are 1, 2, 3, 4 and so on. What are the conclusions? The first one, for n equal to 0 or negative value, the electron orbit doesn't exist because it depends upon the energy. The next one, greater the value of n, the further the electron is away from the nucleus, and n equal to 1 denotes the ground state of an electron. Orbital quantum number is the next quantum number. This quantum number specifies the shape of the orbit. It also determines the magnitude of electron angular momentum. Now if we solve the radial equation A using Legendre polynomials that satisfy the following condition, and that condition is principal quantum number must be equal to or greater than L plus 1. This will give us the orbital quantum number as L equal to 0, 1, 2, 3 up to n minus 1. It is customary to specify the angular momentum states to an alphabet as L equal to 0 is S state, L equal to 1 is P state, L equal to 2 is D state, and so on. And some examples are given here below. For state n equal to 0, then we have a 2s state, and for n equal to 4, L equal to 2 is a 4d state. Magnetic quantum number ml determines the number of orbitals and the orientation in a subshell. So we consider equation 6, it is minus 1 upon phi d square phi by d phi square is equal to ml square. The solution for this equation is phi, which depends upon variable phi, is equal to a e raised to minus I ml phi, equation 7. There are boundary conditions that satisfy the above solution. The first one is the wave function phi must be continuous. The function phi must be periodic, that is phi of phi is equal to phi plus 2 phi. Using the boundary conditions in equation 7 will give us a e raised to minus I ml phi equal to a e raised to minus I ml phi plus 2 pi. So if we solve this equation, we will get the values of ml equal to 0, plus or minus 1, plus or minus 2, up to plus or minus L. In summary, we have obtained the three quantum numbers, total quantum number n equal to 1, 2, 3, 4 and so on. Orbital quantum number L equal to 0, 1, 2, 3 up to n minus 1. Magnetic quantum number ml equal to 0, plus or minus 1, plus or minus 2 to plus or minus L. The various notations used in this presentation. The books and references used are given in this slide, and thank you.